Right, so when we look at quadratic equations, now quadratic equation, first of all, how does a quadratic equation looks like? So it has that certain formation, how it is, right? So the meaning of quadratic equation is, first of all, there's only one variable. Okay, and what is that variable again? Usually it would be x, okay? Alright, and what is the highest index of that variable that you have? X squared, right? So the highest index, that index is that power. So the highest power would be the number 2, alright? So you have in this form ax squared plus bx plus c equal to 0. Now, please understand that the difference between that a, that b, that c, and x. Now, x is a, again we say, x is the variable. And what is a, b, and c? They are just numbers. They are constants. They are not variable. Now, for a particular instance in this equation, for example, that ABC does not change, but the x changes all the time for it. Okay, so that's why x is a variable, but a, b, and c, they are just unknowns. They are constants. They are just unknowns. So once you identify what a, what b, what c is, it doesn't change for this particular equation, but the x still changes at all times, right? So that's the reason why we differentiate these two and say x is actually the variable, but a, b, c, they are just unknowns. They are constants, okay? Now, because in this sense, especially that a and b, we also call that they are the coefficients of x squared and x respectively, yeah? And c is a constant for this particular equation, right? Now, in here, then we have these things that we want to look at would be, what do you call x? What do you call x? X has a name, right? So what is the name of this? What do you call x? No, it's not an unknown. What do you call x? When this equation equal to 0, x is called the values of x are called they're called the roots. So the roots of the quadratic equation, what does that mean? It means find out the values of x. Okay? Alright? So these are the roots. Okay? So it's called the roots. Now, given a quadratic equation, a x squared plus bx plus c, what are the roots? Your favorite. Your favorite formula. What are your roots? So it will be minus b plus minus square root b squared minus 4ac over 2a, right? Okay. Now today, what we want to look at is this thing in here. Alright? So we're going to give this thing a name. Alright? So the name is called discriminant. Okay? So sometimes it's just capital D and we say it's b squared minus 4ac. So was it good? Alright? Okay. Now what we want to look at would be, okay, so I'm going to proceed, yeah? Okay, what we want to look at is now, what is, okay, given, okay, I'm going to write again, ax squared plus bx plus c equal to 0. The root of this is x equal minus b plus minus square root of, instead of writing all that, I'm going to write capital D now. Oh, you okay with that? Over 2a, yeah? Okay, now, this is what we want to look at. What are the possibilities of D here? What are the possibilities of D? Now, generally, we can group this D into 3 categories. Okay? Let's go for something that is easiest. Okay? I'm going to go into something that you asked earlier. So we're going to go into that, the easiest. What would be the easiest number that you're going to put in there? What's the easiest number? Yeah, how about that? Huh? So if D, okay, wait, I'm going to put if D is 0, so it'll be easiest, right? If D is 0, square root of 0 is 0. What are the roots then? Huh? What are the roots of this equation? It would be minus B plus 0 or minus 0 over 2a. What on earth is plus 0? What on earth is minus 0? Are we not saying the same thing? We are actually saying the same thing, right? So which actually means, what are the roots? It's just minus b over 2a. Actually it is one root. But, hey, this is a quadratic equation. What is the meaning of quadratic? Because it is x squared, so you must have two roots. But now what we're saying is that these two roots happens to be the same. Okay? So one good example is like, for example, we did earlier factorizing, remember? So when you did factorizing is x plus 1 bracket x plus 1, for example, then that two values of that x is actually the same thing. But it is a quadratic when you expand it, right? So it becomes a square. Okay? So this is what we say. Because it is quadratic, that's why you must have two roots. But it just happens that the d is 0. So the two roots are the same. So we say if the discriminant is 0, what do you know about this particular quadratic equation? So this particular quadratic equation, it has two real and equal roots. Yeah, that's what we say. Okay, so you have two real and very bad handwriting. Equal roots. Okay? So meaning the roots are the same. Okay? So the roots are the same. But do you really know the roots? Unless you know what A is, what B is, what C. Otherwise, you have nothing. You wouldn't know what the roots are. Okay? In this case, it is, but I mean, they are the same thing. Alright? But it's supposed to be R because you should have two roots. Okay? So now what I want to emphasize here is that when you are evaluating D, the discriminant, you are purely testing what the roots are, not necessarily working out what the roots are. You're just testing how these roots are. Okay? Right? Are we okay? Yeah? So of course, the second scenario would be if D is greater than 0. So if D is greater than 0, then what do you know then? Then it will be minus B plus something. Again, let's try something very simple now. This time you cannot use 0 there anymore, right? So let's say something like simple number 1, for example. Then you know square root of 1 is still a 1. Then you have minus B plus 1 divided by 2a. Or minus B minus 1 divided by 2a. Is there a possibility that these two would be the same? Is it possible that the two are the same? One you say add 1, another one you say minus 1, and then they are the same? It can never be the same, right? It's not possible at all. So what are we saying now? Will be these two roots, they are definitely different. They cannot be equal anymore. You just say they're not equal. Because you add 1, let's say, you add 1 or you minus 1, right? Then they cannot be the same. So meaning what we're saying now is that if D is greater than 0, then you get two real, if there are still real roots. Okay, two real, and then they are distinct. So the word that we use is distinct. So distinct means different, yeah? So distinct means different. Okay, so that's the word that we use, distinct. Okay, so what we're saying is that these two roots, they are definitely different. There's no way that they will be the same. Okay? It is still real numbers. Alright? What is the meaning of real numbers? They are practically any numbers. Whatever that you can put on the number line. Alright? They're almost any numbers that you know right now. Okay? There's another type of number which will be introduced to you 2 years down the road, not now, but right now, everything, if you can put on a number line, it is real. Would there be a possibility that you cannot put on a number line? Would there be? Because I just say that practically anything you can put on a number line, right? But do you think there will be something that you cannot put on a number line? You think so? Now what if we have the d equal to 0 and we have d that is greater than 0, then if you just look at this d here, there is also a possibility that the d is smaller than 0, right? What if d is smaller than 0? Then you're going to look at minus d plus or minus square root of negative 1. What on earth is that? This is one example where you cannot put it in a number line. Right? So this is one example that you cannot put it in a number line. Alright? So what we're saying right now, this now, it works so simple. Because why? Because we have no real roots. No real roots means don't need to work hard. Simplest, isn't it? Okay, no need to work. Alright, so this will be the 3 scenarios. This will be the 3 scenarios in specific. This will be the 3 scenarios of how the roots can behave. Okay, so either the discriminant is equal to 0. If they're equal, then you have 2 real and equal roots. If they are greater than 0, or rather if the discriminant is greater than 0, then you get 2 real and distinct. So that 2 roots, they must be of different values. Okay? Or if the discriminant is less than 0, then voila, nothing to do because you can't do anything. Right? So that says you have no real roots. Okay? Right. Okay? How about that? Just try that 1, 2, and 3. Just test that, taste that, and see how you use this information. Yeah? Of course, like for example, the question 1 actually tell you, first, you do that test, the test of the discriminant. If it is real, then you proceed to find the roots. If it is not real, it just stops there. Okay? Yeah, alright? Okay, so just try that first, and then we'll see. Alright? Okay.